We will start, sir.
Okay, madam.
Yes. So good evening to all the participants and the faculty members who have joined here. And because of the organizing team, I welcome you all for the day 3 session 1 on this Friday online FDP on advanced signal processing communication using AI and ML techniques. Today we have as a speaker Dr. K. Krishna Kishore. He is currently working as a senior assistant professor in the Department of ECE at GMR Institute of Technology, Rajat. Having 12 years of teaching experience in GMR Institute of Technology, he is having more than 25 number of publications in various journals and conferences. He has organized more than 10 FDPs and workshops in the field of electronics and communication engineering, and he has also delivered more than 10 talks in faculty development programs and workshops in the area of wireless communication. And he is also a member in the professional bodies such as IST and IET. He has received the grant from AICT for the conduction of various club activities for the students of GMRIT under a SPICES scheme. He has published 3 patents to his credit, and he has guided a UG project which has received won the prizes from the various competitions conducted by the governments and non-government agencies. And he is holding presently an active researcher in the field of wireless communication. So with this brief introduction, I would like to invite Dr. K. Krishna Kishore sir to take over the session.
Good afternoon, everyone.
Good afternoon, sir.
Sir, can you see the screen?
Yes, sir.
Yes, sir. Yes, sir.
Yes,
It is
sir.
visible.
Yes, sir.
Okay, madam. Today we are going to discuss regarding the artificial intelligence, machine learning, and deep learning algorithms, and what is the difference between this AI, ML, and deep learning, and what are the applications involved in these three, with some real-time applications we are going to learn in this session. Coming to the definition of AI is the artificial intelligence which makes the machines to learn and adopt the new things that can take the decision like a human. These artificial intelligence are further classified into machine learning, deep learning, and in deep learning you will have neural networks. In case of machine learning, it is an algorithmic approach. It is an algorithmic approach where we use different algorithms to classify or to train the machine and to adapt the machines for the real-time situations. In case of deep learning is basically works with neural networks where it will basically use a CNN and RNN model, and the structure of deep learning is basically purely depending upon how the human brains is working. That is the major difference between artificial intelligence, machine learning, and deep learning. Machine learning purely talks about the data, whereas in case of deep learning, we take mostly on images. So if you see the structure of human brains, in generally in human cortex, we have 10 billions of neurons. Whereas in case of powerful parallel computers, we will have 10,000 of processors. A human brain, one neuron is always equal to one processor. So if you see the typical operation of a neuron, to stimulate, it requires 10 power minus 3 seconds. Whereas a supercomputer or a silicon chips, at present we are having the technology of 10 power minus nanoseconds or nanotechnology. So when compared to the computers, the speed of the human brain is very fast, and the number of And the energy required to perform one task by the human brain is around 10 power minus 16 joules, whereas the energy required for performing a computer is 10 power minus 6 joules. So in terms of speed, in terms of energy requirement, always human brain is more superior when compared to the computer. So basically, we think with different frequencies. If a human brain is thinking the frequency when you're talking about 30 to 35 Hz frequency, if a person is concentrating or thinking or taking any decision with a frequency of 30 to 35 Hz, the status of the brain is he's more concentrated towards his work. If a person frequency, the range of frequency, the thinking frequency of the person is around 12 to 35 Hz, this frequency we'll call it as beta, where he will be more anxiety and he will be more attention for the actional activities. If a person's frequency is around 8 to 12 Hz, that talks about the alpha range, then that is the relaxation state of the mind. So when you are relaxation state, the frequency of your brain waves will be around 8 to 12 Hz. When you are in a sleep mode, it is a delta range. The frequency of the brain waves is around 0.5 to 4 Hz. So coming to the internal structure of a basic biological neuron will have dendrites. Dendrites are the inputs which take data from the sensor organs like eyes, touch, ears, etc. These dendrites will take the inputs and these inputs will be transferred to the cell body. That the cell body we are considering as a processor is nothing but nucleus or soma. This synapses is the link between one neuron to another neuron, and these axons are nothing but the outputs. So if you take the artificial neurons, in place of dendrites, we have the inputs and we have the weights. And the artificial neuron is combination of one linear combination of inputs with weights and a activation function. So if you have a comparison between a biological neuron and the artificial neuron, a biological neuron we are calling as a cell, that is the processing unit, or that is considered as a node in the artificial neuron. The dendrites which take the inputs from the sensory organs will be considered as inputs in the artificial neuron. The synapses which connects one neuron to another neuron is nothing but the weights or the interconnection between these two neurons. And the axons are the outputs. So this is the differentiate how the model of ANN is derived from the human brain. Here, usually during the childhood time, we used to do the things repeatedly. When we used to do the things repeatedly, like when we want to learn a particular lesson, we used to learn for 10 to 15 times. When you are learning for more time, the strength, the signal generated by the synapses will be very high. That is nothing but sodium plus Na plus. When the signal generated by the synapses will be very high, the bond between one neuron to another neuron will be very high. When the bond between one neuron to another neuron is very high, which indicates that you can remember that particular event for a long period. So whenever you want to recall it, there is a link between this neuron and that neuron. That link is very highly bonded, so you can easily remember the things. So that is the major reason why during the school age, teachers used to tell to learn more times. So when you want to learn anything when you're doing the particular task many times, the bond between the synapses link will be very high so that you can easily remember the things. So the dendrites the dendrites can be replaced with inputs. The soma or the cell body are replaced with the node, and the synapses, which is the interconnection between the one neuron to another neuron, are replaced with weights, and the axons are nothing but our outputs. So the basic artificial neural networks will have inputs, nodes. Each node is again in see the combination of this linear combination and threshold or activation function can be considered as one node. For simplicity, we are showing in a different way, but each neuron will have active combination, that is the summation of inputs with weighted vectors as well as activation functions. So this is the basic difference between a biological neuron and artificial neurons. Suppose if you take a single neuron is having 5 inputs x1 to x5, and each input is having some weight w1, w2, w3, w4, w5. Here the summation unit will do operation that x1 w1 plus x2 w2 plus x3 w3 plus x4 w4 plus x5 w5, and this resultant is given to the transfer function. This is nothing but activation functions. We are going to discuss different types of activation functions in the next point. By depending upon the function of the activation function, you will get the output. In a similar fashion, how you are getting the, suppose any insect has hit on your body, the particular skin organs will send a data to the dendrites that there is a problem. This will be given to the soma or cell body, which immediately will pass a high electric pulse signal to the synapses. So immediately your hands will have and it will hit that insect. This is the operation what will happen inside the neuron. The same thing will be happened here. If the weight of a particular function is very high, you will react for the particular input. So this is the structure of a single neuron. Generally, artificial neural networks will have major 3 building blocks. One is network topology, another one is adjustment of weights or learning. Adjustments of weight is a important process in ANN, and the third one is activation function. These are the 3 important parameters while you are discussing about artificial neural networks. So first we are considering a simple single layer feed forward network. A simple single layer feed forward network will have only input layer and output layer. And why it is named as feed forward network is the data is moving towards from input layer to output layer in only one direction. So here input layer you will have x1, x2, x3, x4, and you will have output layer y1 and y2. So each input layer will have some weights. So this y1 is the product of x1 w1, x2 w3, x3 w5, and x4 w5. That will be your y1. And y2 is the product of x1 w2, x2 w4, x3 w5, and x4 w7. And this output layer is a common linear summation of the input layers as well as activation function. If the summation is below the threshold level of the activation function, the output will be 0. If the summation value is above the threshold level value of the activation function, output is 1. That means here, see, when you are feeling cold, similarly you will keep your hands near the fire. At what instant you can take the hand is depending upon the pulse that is to the soma to synapses. So when you feel the war, the pulse generated by the cell body to the soma is, the electric pulse is very low level. When you feel very hot, the electric pulse generated by the soma is very high, above the threshold levels. The threshold level, what we are talking is activation function there. If the electric pulse is very high, since due to this high electric pulses, immediately the person will remove the hand from that position, since he's feeling very hot. So apart from single layer feed forward multi neural networks, we have multi-layer feed-forward neural networks. In case of multi-layer feed-forward neural networks, you will have more number of hidden layers. You have one input layer, one hidden layer, and one output layer. Hidden, if the number of hidden layers are very high, that network we will call it as deep network or deep neural networks. Deep neural networks basically will have more number of hidden layers. And the deep neural networks will majorly focusing on the data which is related to the images. And the third type of neural networks what we had is recurrent neural networks. In case of recurrent neural networks, there is a feedback from the one layer to the previous layer. So we have three types of architectures. One is single layer neural networks where you have only input layer and output layer. Another one is multi-layer neural networks where you will have input layer, more number of hidden layers and output layers. If the number of hidden layers is very high, those networks we are considering as deep neural networks. And the third category comes under recurrent neural networks where there is a feedback between the layers. So these are the characterization of different types of neural networks. Now coming to, as we are discussing that each node in a neural network is a linear combination of input data and activation function. If we don't have a activation function, our neural network is similar to the algorithms which is only applicable for linear data. If we don't have a activation, the neural network is nothing but it performs the operation on a linear data. It will multiply input x1 with w1 plus x2 with w2 and x3 with w3 and so on. So activation functions plays a major role and it increases the compatibility of the neural networks for wide
So Kishore sir, I think you are muted. Kishore sir. Dr. Kishore. Check sir, you are not audible.
Sir, is it okay?
Yeah, okay sir. Now it is audible. Please carry on sir.
Now, sir, while
Now?
I'm using the camera, it is okay?
Oh yeah, it is okay sir. It is fine. It is
Okay.
good. Yeah. So, okay sir. Please carry on.
Okay. So every neuron is a linear combination of input vectors with weighted functions and activation function. Activation function plays a key role or major role to make the neural networks for wide area of applications for nonlinear applications. If you are not using any activation functions, neural networks can be useful only for linear applications. So one of the simple activation function what we are using is binary activation function. The binary activation function tells that the output of the neural network, suppose if I had two input nodes x1 w1 plus x2 w2, if this value will be, we are considering y of x, if this value is greater than or equal to 0, the output of the particular neuron will be high, 1. If this value w1 x1 w1 plus x2 w2 is less than 0, the output of particular neuron will be low. So this is the basic activation function, which is nothing but binary activation function. And the second activation function is sigmoid activation function, where sigmoid activation is that which indicates that if the value of y of x is greater than 0.5, the output of the particular neuron will be 1. If the value of y of x is nothing but the combination of input vectors with nodes is less than 0.5, the value of the function is 0. In a similar way, we have tan h function which will have both sides. That means here the activation functions will be applicable more than binary. That means here if the value of the linear combination y of x is greater than 0, then the output of the particular neuron will be 1. If the value of y of x is equal to 0, the output of the neuron will be 0. And if the value is y of x is less than 0, the output will be -1. So when you are using tan h function, each neuron at each stage, we had 3 outputs, depending upon the input combination. Suppose if you observe here, I had 2 inputs, and W1, W2, W3, W4. Here, let us assume that my intermediate output is H1, where H1 is equal to X1, W1 plus X2, W2. If this particular value, after taking the linear combinations, is less than 0, then when you are using the activation function as tan h, that function will provide an output is -1. If it is equal to 0, that function will provide output as 0. That means this neuron output may be 1, 0, -1, which is given as an input for the next stage. Similarly, we had ReLU function and leaky ReLU functions. These are the activation functions what basically majorly many applications, image processing, any application, basically they go for ReLU and sigmoid functions. And one of the another activation function is softmax. These softmax functions is basically used at the output layer. And ReLU sigmoid functions can be used in the hidden layers, but preferably the softmax functions can be used only in the output layer. The reason is, suppose if I had 4 x1, x2, x3, x4, 4 inputs, and I had one output layer W1, W2, W3, W4, which produces a value of 7, 4, 5, 3. This softmax function, what you will do is, for calculating this particular output Wy, what it will do is 7 by 7 plus 4 plus 5 plus 3. And if you want the output for 4, it will do 4 by 7 plus 4 plus 5 plus 3. And it will perform exponential operation. So that is the advantage of your softmax function when compared to other layer. So is it clear regarding this activation functions and the inputs? Now we will go with a real-time example how to implement a neural networks for a pattern recognition. Here, even though I'm telling problem implementation of AND gate and OR gate is nothing but a, suppose if you take a AND gate, in case of AND gate, you have 0, 0, 0, 1. Let us take a two input AND gate, 1, 0, 1, 1, A and B, which produces output 0, 0, 0, 1. This is my targeted output. See, here it is not the numbers what we are talking, it is the pattern. Pattern means when a hash pattern is 0, 0, my target output is 0. When my pattern is 0, 1, my target output is 0. When is 1, 0, my target output is 0. When my pattern is 1, 1, my target output is 1. Since the number of inputs here is 2, I require 2 input nodes. That is A and B. Okay. Now, since I had only one output, I required one output node Y and weights W1, W2, which produce output Y. Now, if as we discussed previously, hidden layers or output layers, each and every neuron is a combination of, in some textbooks, they will give different separately for activation function and separately for neurons. Every neuron is a combination of linear summation of the input vectors with weights as well as activation functions. So here, let us assume our weights are 1, 1. W1 is equal to 1 and W2 is 1. So initially for any network, we can assume the weights randomly. Laterally, we have to train the networks to update the weights to get the desired output. Now, my inputs are 0, 0. See, case 1 I'm considering A, B, 0, 0. And my targeted vector is 1, 1. W1 is equal to 1 and W2 is equal to 1. Now, here, your output Y is equal to, as you know that X1 W1 plus X2 W2 is the formula for this particular neural network. X1 is 0, X2 is 0, therefore Y is equal to 0, Y is equal to 0. For the second combination 0, 1, Y is equal, for 1, 1, what will be the Y? X1 0, W1 is 1, 1, 0 plus X2 is 1, X2 is nothing but B. You consider X1 as A and X2 as B. B is 1, W2 is 1, 1 into 1 is 1, therefore 1. And the third case, 1 and 0, if you take Y, 1 plus 0 is 1. And the fourth case, 1 comma 1, Y is 2. Now, the output of this particular neuron you got for the combination of inputs and weights are 0, 1, 1, 2. This is your actual output. What should be the activation function I have to keep for this particular problem? Any guess? To get the target output, what should be the activation function activation function value I have to consider, so that my network will give exact results for a AND gate. Or for a pattern, it has to recognize 1, 1. It should give the output as 1, and for the remaining cases, it should give the output as 0. Here, I have to consider the activation function as, since if you observe that 0, 1, 1, for the fourth case, 1 plus 1, 2, if I consider activation function, that if my output value Y of X will be 1 for Y of X is greater than or equal to 2, or else it is 0. Is it clear? So in that case, first case, the output is 0. Therefore, the output of this particular network is 0. Second case, the output is 1. Since the activation function will be high only for greater than or equal to 2. Therefore, it is 0. Third case 0. And the fourth case, the actual output is 2. Now you are comparing this output with your activation function. Activation function value is 2. 2 is equal to 2. Therefore, this neuron will give a output is 1. This is how you have to fix the activation functions. Now we will see one more pattern recognition, which is nothing but a OR gate. So if you consider OR gate, again I'm considering inputs A and B, Y 0, 0, 0, 1, 1, 0, 1, 1, 1, 1, 1. See, in this pattern, if the pattern is 0, 1 or 1, 0, 1, 1, the output should be 1, and this case 0. So you have two inputs. So you take two input nodes, A and B. Okay. Since you had one output, you take one output node and W1 and W2 are the weights. Randomly consider one. And you check whether what should be the value of activation function so that this particular neural network will produce a pattern of this one. As you know that this neuron is a combination of linear combination of inputs as well as weights and an activation function. Now, by observing the data, I should in a position to know what should be the value of activation function so that it will produce this pattern. So as you know that y is equal to a w1 plus b w2. As we have fixed w1 and w2 is equal to 1. And you apply the first case 0, 0. When you apply the first case 0, 0, a 0 and b 0, therefore your output will be 0, y is 0. For the second pattern for the second input, when you are giving to the network, that is y 0, 1, your output y is 1. For the third input, network 1, 0, your output y is 1. For the fourth input, when you give as for the network, your output for 1, 1, y is 2. Now, this y data will be transferred inside the neuron to the activation function so that this neuron will produce output. Now, what should be the value of this activation function I has to take so that I will get this pattern? Any guess from this? What should be the value of activation function? Here you observe that output what you got from the linear combination is 0, 1, 1, 2. And my targeted outputs is 0, 1, 1, 1. For this output linear combinations, when I transfer this one to a activation function, I should get this one. Now, what should be the threshold I have to keep? Activation function is nothing but a threshold value where if your linear combination of the particular neuron is below the threshold value, it produces the output is 0. If the linear combination of the particular neuron is above the threshold value, it produces the output 1. Can anyone give the guess what should be the threshold value here? Here the threshold value what we have to take is f of y should be 1 for y greater than or equal to 1. F of y is equal to 0 for y less than 0. If I keep the threshold like this, now in the 4 combinations, I got 1, 1, 2. For these 3, my threshold is greater than or equal to 1. So the output of this neuron will be 1, 1, 1. And during the first pattern, when you are giving 0, 0, your output is 0. Since y is 0, for y less than or equal to 0, f of y will be 0. Therefore, this neuron output will be 0. So it will produce or it able to recognize this particular network and able to recognize the pattern that it can get the output for 0, 1, 1, 0, 1, 1 as high and for 0, 0 as a low. This is how you can implement any pattern recognitions by using simple basic neural networks. And coming to the machine learning algorithms, a machine learning algorithm, the basic machine learning algorithms is, before we are going to train, suppose if you take a newborn baby, if I give an apple to the newborn baby, she cannot recognize whether it is an apple or cherry or an orange. So what I have to do is, every time I should bring an apple and I should tell that this is apple, this is apple, this is apple. That is what the training one. So after a certain period, that machine or the baby able to recognize when you are giving the particular item, whether it may be a cherry or it may be an apple or it may be an orange. So in this algorithm, each neuron should have an output of 3 levels. Here you have 3 classifications: cherry, apple, and orange. So in this case, you cannot use a binary classifier at the output stage, which can classify only 2 classes. So depending upon the number of outputs, we have to check your classifier activation functions. So in generally, machine learning algorithms are classified into 3 categories. One is supervised learning, unsupervised learning, and reinforcement learning. A supervised learning means the learning will be happen in the presence of the supervisor. That means you have to give the output as well as input for the machine. So the output is known and the input is known to the machine in case of supervised learning. In case of unsupervised learning, it is a learning happen without any supervision. That means you have only the input data, you don't have the output data. And the third one is reinforcement learning. In case of reinforcement, it is a experience-based learning where there will be a target and there will be an event. Whenever the particular agent will be succeeded the event, he will be awarded. Or if he not succeeded the event, again retrain the things. This is a experience-based learning. So coming to the supervised learning, we have, in case of supervised learning, directly you give the inputs and outputs to the machines. Sir. So in case of supervised learning, you will have input data and output data to the machine. And these supervised learnings comes under 2 categories. One is regression, and the other one is classification. In case of unsupervised learning, you will have, again, these unsupervised learning are of 2 types. One is association and the other one is clustering. And reinforcement learning is nothing but it is a self-based learning where a event is given and it should be adapted for that particular situation. Now coming to the regression types. In case of regressions, we can use 2 types of thing. One is linear regression and polynomial regression, or decision tree, or random forest algorithms. So whenever you are working with respect to the regression type algorithms, we can use linear regression type algorithms, or polynomial algorithms, or decision tree algorithms, or random forest. And coming to the classification type, in case of classification algorithms, classification means the purpose of the classification algorithms is it has to classify whether, suppose if I had 3 animals. So you will train the, in case of supervised learning. In case of supervised learning, during the classification panel, Suman, Suman, Suman. నాయిస్ అయితే వస్తుంది. As we know that regression will work with the real-time data, and basically these regression types are basically used for analyzing the stock market to predict the future value of these things and to predict the rainfall, etc. And basically for when you are working with this real-time data, then you go with the algorithms like linear regression algorithms or logical regression algorithms. Okay, coming to the classification. In case of classification, the purpose of the classification is to classify the data into different categories. Suppose if you train the system with all apples and oranges data, when you give a new set of data, depending upon the parameters or the features what you has taken, it has to classify whether the particular class belongs to orange or apple. Or suppose if you want to work with the numbers 0 to 9, whenever you write a new number, it has to classify whether the number belongs to 9 or 1 or 2 or 3 or 4. For these type of classifications, we will go basically with K nearest neighborhood algorithm and logistic regression, Navi-based algorithm, and support vector machines. So is it clear regarding the supervised learning? Supervised learning means the machine will knows what is the output and what is the input, and you have to give the training depending upon the in presence of the supervision. And to supervised learnings are classified into two types. One is regression and then another one is classification. Whereas regressions is basically work with real-time data. Some of the examples where you can apply the regression type supervised learning is regression algorithms is one is you can predict the stock market data or well as predicting the weather forecasting, whether there is a rain or not. And some of the basic examples for classification learning is KNN and SVM. In case of regression, we are using linear polynomial, linear regression or logistic regression. Now coming to the second type of machine learning is unsupervised learning. In case of unsupervised learning, a raw data is given to the machine. Here, the machine don't know what is the output. But in the previous case, we have to train the machine with respect to the output. Here, a raw data is given to the machine, and from that raw data, it has to extract the features. And from that feature, it has to divide the data into clusters. Again, these unsupervised learnings are classified into two types. One is clustering, another one is association. In case of clustering, suppose a similar features is suppose some set of data is having the similar features, it brings into one cluster. Suppose if I want to apply the clustering, I want to in a college, depending upon the subjects studied by the students, I want to group them into clusters. I will give a set of subjects from the first year to final years. And if the student studies this set of subjects, he belongs to ECE. And I will give another set of subjects. If the student is studying this set of subjects, he belongs to CSC. And I will give another set of subjects. If he studies all these set of subjects, he belongs to EEE. So when you apply a K-means algorithm or PCA or SVD, depending upon these features, it will divide the data into clusters. So this is regarding the clustering algorithm. In case of association analysis which comes under supervised learning. So depending upon your present input, it will produce the similar outputs. That means suppose when you are searching for a Google, you want to buy something like a mobile phone in the Amazon, you will search for the mobile phone in the Google. If you observe that after a certain period, all the ads related to the mobile phones will be appearing while you are going for any search. all the ads will be appeared while you are going for search. Starting will be appeared as a search. And the third type of learning is reinforcement learning. Here, in case of reinforcement learning, only you will have two things. One is agent, and the one is enrollment. In case of reinforcement learning, the agent will be exposed to a new environment, and if you perform the task correctly, the agent will be awarded with 1 token. And if he's not performing the task perfectly, the agent will be demotivated with 1 token. Again, he has to relearn the things. That is the concept behind reinforcement learning. Suppose if I take a driverless car, one of the best example for reinforcement learning is driverless car. If I take a driverless car at a junction, at a T junction, if actually the car has to move towards the right. If it is moving towards the right, then it gains the token and indicates that it is working correctly. Suppose at this T junction, in spite of moving this side, if it is moving this one, and a token is debited from the agent, and the agent again it should be retrained for that particular enrollment, and it will be stored in the data. So whenever the particular situation comes, by considering the previous experience, the agent has to perform the task. The agent has to perform the task. So this is regarding the reinforcement learning. So some of the algorithms what we use for supervised learning, unsupervised learning, and reinforcement learning is, in case of reinforcement learning, we use Q learning, R learning, and TD learning. And already we have discussed regarding the remaining parts. And these are the applications where you can apply the supervised learnings. If you want to apply for supervised learning, the applications are like fraud detection in ATM cards and email spam, diagnosing whether the particular person is having a particular type of diseases, and image classifications all comes under classification techniques, which comes under supervised learning. Supervised learning is a label learning. That means you have to give the output label, whether that particular classes belongs to cat or particular classes belongs to dog, etc. In case of supervised learning, the other one is regression type. Regression type is basically for prediction. So when I want to invest something in the stock market, what is the risk assessment? That for those kind of problems, you can go from time. And for the prediction of stock, what is the value of the particular company? For that, you have to go for regression type. And coming to the unsupervised learnings are applied for the applications like image recognition, big data visualization, face recognition, etc. And coming to the reinforcement learning is basically used for gaming and finance sector, manufacturing, and one of the best example for reinforcement learning is driverless car. Now we will see how we will apply one algorithm, that is KNN, which comes under supervised learning for a real-time problem. So when you want to apply a KNN for a real-time problem, the first thing is you have to take the data. After taking the data in KNN, you train the machine with that particular data. Whenever a new data set is arrived, this machine will find out a equivalent distance between the present data and the new data set. After finding the equivalent distance between the present data set and the new data set, then it has to take the decision by considering the number of numbers we are allocating. We'll see now how a KNN works on a real data set. Now, I have taken a data set that a student should qualify for the placement if he scores 6 marks in quantitative aptitude and 7 marks in soft skills. Then he will be qualified or he will be passed. And a student who scores 7 or 8 will be more than 6 will be qualified. And if a student scores 5, he will be disqualified. Here, if the student 5 is scoring 8, he will be qualified. Here, student 1 is scoring 4, 3, he will be disqualified. So this is the data set what I had, and I had trained for mission by using KNN. Now, I had a new sample that one student who got a marks QA is equal to 6 marks and soft skills is 8 marks. And by using I predict whether this student is eligible for placement or not. In that case, what I will do is, how the KNN algorithm will work is, KNN algorithm will perform a equivalent distance between S6 and S1. That means S1 comma S6 is root over x1 minus x2 whole square plus y1 minus y2 whole square. See here it is 6 minus 4, 2 whole square plus 8 minus 3, 5 whole square. So if you perform this equivalent distance between S1 and S6, the value will be around 5.3. In the second case, again you perform the new data with S2 and S6. If you perform the equivalent distance between S2 and S6, S2 is 6, 6 minus 6 is 0, 0 square, 8 minus 7 whole square is 1, therefore the value is 1. If you perform equivalent distance between S3 and S6, here S3 is 7, 6 minus 7, 1. And soft skills value is 8, 8 minus 8 is 0, therefore it is 1. Similarly, perform the equivalent distance between a new sample which you are given to the data, that is the test sample, and these are the trained samples. And these are the outputs of the trained samples. Okay. Now, when you are giving a new set data sample, for when you're comparing this, when you're finding the equivalent distance between S1, S2, S6, S2, S6, S3, S6, S4, S6, and S5, S6. So these are the values. Now, here I have to define K. The K here represents the number of nearest neighbors. K nearest neighborhood algorithm means when I am taking the decision by using this algorithm, I have to consider minimum 3 neighbors if I am assuming K is equal to 3. If I keep K is equal to 5, before taking the decision while applying the KNN algorithm, I have to at least consider 5 nearest neighbors. Now, here in this case, I am considering K is equal to 3, which indicates that before considering a decision on S6 data, I have to consider a minimum of 3 neighbors. After 536 minimum 3 neighbors. Now, nearest neighbors. For finding the K nearest neighbor, you find out a minimum value between these two. 5.3 minus 1, 4, it is high. 1 minus 1, 0. The distance between these two neighbors are very less. So these two neighbors are very close to each other. And 1 minus 3.1, 2. And 1 minus 1, 1 minus 2, 1. So if you observe these combinations, the distance between S6 and S2 is less, and the distance between S3, S6 is less, and the distance between S5 and S6 is less. So since I'm considering K is equal to 3, my 3 nearest neighbors are S2, S3, S5. Is it clear this point? My nearest neighbors are S2, S3, S6 for K is equal to 3. Since my nearest neighbors are S2, S3, and S6, I have to check what is the data or what is the condition of these three neighbors. S2, pass. S3, pass. S6, not S6, it is S5, sorry. S5 pass. Since all my nearest neighbors are passed, I has to give that the new neighbor S6 is also qualified for the exam. This is how a KNN algorithm will work. Here, but in this case, we got 3 is pass conditions, but there is a ambiguity that S2 may pass, S3 may pass, S5 may fail. Then in this condition, you have to give that S6 is also a qualified person like pass. Since the majority of the neighbors are passed. Suppose if I take the third condition where S2, S3 or S6 are identified as a nearest neighbors. If I'm considering a case where suppose if S2 is failed, S3 is failed, and S5 is pass. Since the majority of the nearest neighbors are failed, the particular person who data you have test should be failed. This is how a KNN algorithm works. Is it clear regarding this algorithm? Is it clear? See, I'm repeating KNN algorithm. In case of KNN algorithm, initially you will train the data with data set. Now, once you train the data with data set, samples for the mission, equivalent distance between the new sample and the data in the data set. Equivalent distance means it will find distance between S6 and S1, 6 minus 4, 2 whole square plus 8 minus 3, 5 whole square. Square root of 2 plus 2 square plus 5 square, it is around 5.3. In a similar fashion, it has to perform the equivalent distance between all other samples. After performing the equivalent distance between all other samples, now you have to find out what should be the value of K. Let us assume, I am assuming the value of K is 3. Always prefer that you should have in KNN algorithm, the K value always preferably should odd. If you take a K value as even, you will come across a hypothetical cases where 2 people are pass and 2 people are fail. Then you cannot judge, depending upon the 50% of data, you cannot judge the new person. So that is the factor where you have to assume always the K should be in odd number. Now, after finding the equivalent distance between these things, now you have to check who are my nearest 3 neighbors. Since my K is equal to 3, I have to identify my 3 nearest neighbors. For that, you find the difference. Difference is 4.3. Find the difference. Difference is 0. Find the difference. Difference is 2.1. Find the difference. Difference is 1.1. Find the difference. Difference is 1. Now, from this data, you can observe that my nearest neighbors are this one, and this one. That means for S6, my nearest neighbors are S2, S3, S5. Now, I have to check what is the condition of these 3 neighbors. Depending upon the condition of these 3 neighbors, I have to give a token for S6. Now, if I see S2 is passed, S3 is passed, S5 is passed. Since 3 neighbors are passed, I'm giving S6 is passed. If any 2 is passed, you can give S6 is passed. or else as if two are satisfied. This is how a KNN, a supervised learning, will work. Now, one of the important model for designing or for learning any machine learning or deep learning or artificial intelligence is perceptron. Perceptron is the basic building block of your ANN. In generally, a perceptron will have X inputs and X weights and a bias. After bias, you have an activation function. So this is how we are showing the activation function in a different way, but you can show the activation function inside this also. This activation function, this combination is combinedly together. We'll call it as a neuron. Okay. So in perceptron model, if this value of y is greater than or equal to some threshold value, then it will be 1 or it will be 0. Now, how a perceptron will work? Always you have to see your output with targeted output. When your output and target output is same, you no need to train the network by using different training algorithms. If your output and your target output is different, then you have to train the network. Train the network means you have to update the weights. Now, for updating the weights, the formula is the new weight W new is nothing but W old plus del I, where del I is nothing but eta into T minus O into Xi, where eta is the learning rate at what rate your machine is learning, and where T is the targeted output and O is the actual output of your neural network, and Xi is the input. So this is how you will update the weights until your target output is equal to the actual output. Now, let us consider again a problem. We will work on that. Design an AND gate for a given specification by using perceptron. Here, if you observe that previously we have designed the same thing, but there we have not updated the weights. We have randomly chosen the activation function at threshold value depending upon our perception by seeing the output. But in case of neural networks or automation, the system should automatically update the weights. So we'll check one example how a neural network will update the weights or a perceptron will update the weights for a given data. See, and one more important, these perceptron rules are applicable only for linear data. See, if I take AND gate, my pattern is 0, 0, 0, 1, 1, 0, 1, 1, which produces my output 0, 0, 0, 1. For 0, 0, the output is 0. For 0, 1, the output is 0. For 1, 0, this is X, this is Y. For 1, 0, the output is 0. For 1, 1, the output is 1. Now, see if you observe this, this is a linear pattern where you can separate this by using a linear decision line. Now, updating the weights means moving this decision line to separate the pattern exactly. So, initially I can randomly choose the decision line at this point. Initially, randomly, I can choose the decision line at this point. Depending upon the training algorithms, I can train the system. And move the decision line to this position so that if the value below this line is considered as zeros, if value above this line is considered as 1, this 1 is reflected to 1, 1. This is only one pattern which produces 1, and the remaining patterns it produces zeros. Okay. Now we will see how we will train a perceptron model for this particular data set. Since again we are going to the first thing, since we had two inputs, I will go with two input data. Since I had one output, I had only one output neuron. Put y. My threshold or activation function here is 1. That indicates if this y value is greater than 1, the output is 1, or if the y value less than 1, the output is 0. And the learning rate eta, what we have considered as 0.5. And the weights W1 is given 1.2 and W2 is given 0.6. As you know that y is equal to W1 x1 plus W2 x2. For the first sample, I'm training the network for the first sample 0 0. Since x1 0, x2 0, output is 0. Output is 0. This is your original output and the target output is 0. Since your original output is equal to targeted output, then the machine passed the test. No need to update the weights and you can go with the same weights. Y is equal to second set W here x1 x2 are 0 1, therefore it is 0.6 multiplied with 1 is 0.6. 0.6, the value of 0.6 is less than, the value of 0.6 is less than 1 threshold. Therefore, this particular neuron will produce a output 1, the output 0. So your targeted output is equal to the system output, actual output. Therefore, no need to update the weights. Now you check for third input. Third input is y is equal to W1 x1 plus W2 x2. W1 is 1.2 and x1 is 1. This is 0, 1.2. Your threshold value is 1. 1.2 is greater than 1. Therefore, your neural network will produce a output is 1. When the neural network is producing the output is 1, your output is 1, but your targeted output is 0. Since the targeted output is 0, now it is a time to update the weights to get the targeted outputs. So for updating the weights, what is the formula? V nu is equal to V old W old plus eta into T minus T eta into x1 xi. That is x1 here. V is equal to V old. What is W old? First I'm talking 1.2 plus eta. Eta learning factor we have considered as 0.5. And my targeted output, what is the target output here? Target output is 0 minus actual output. What is the actual output I got? 1. 0 minus 1. It is, what is x1? Since I'm talking about W1, I have to consider x1 is 1. This particular A. Therefore, it is 1.2 minus 0.5. It is 0.7. So the new updated weight value of W1 is 0.7 rather than 1.2. Check for second weight, W2 new. W2 new is nothing but W2 old is 0.6 plus eta is 0.5. Actual output, targeted output is 0. Actual output is 1. And xi, now you have to consider 0. So this will be 0, it is 0.6. So there is no updation in the new weight. Therefore, the new weight is 0.6 and the W1 is 0.7. Now, once you have updated the weights, now again for this, once you have updated the weights, you have to check the network for again all the combinations. That is important. 0 0 0 1 1 0 1 1 0 0 0 1. Now again, you have to check the networks with the new weights with for all the combinations. What is the new weights? Now W is equal to W1 x1 plus W2 x2. Now your new weights are W1 is 0.7 and W2 is 0.6. For 0, 0, Y is 0. Since Y is 0, your target threshold value is 1. 0 is less than 1. Therefore, this neural network will produce a 0, 0 and 0. Therefore, target output is, so it passes the test. Consider the second case. For the second case, since W2 is 1, you will get 0.6. 0.6 is less than 1. 0.6 is less than 1. Therefore, the output of neural networks is 0. Since the output of neural networks is 0, the target output is equal to the actual output. Therefore, it passes the test. Now coming to the next third part, 1, 0, 1, 0, 1 multiplied with 0.7 and 0 multiplied with 0.6. Therefore, it is 0.7. 0.7 is less than 1. Therefore, the output of neural networks is 0, 0, 0. Target output is 0 and actual output is 0. So it passes the test. Next case, you consider 1, 1, 1, 1. X is 1, x2 is 1, that is W is equal to 0.7 into 1 plus 0.6 into 1. So it is around 0.7 plus 0.6 is 1.3. Since your summation value is 1.3, which is greater than the threshold value, therefore this neural network output will be high, 1. Your actual value is equal to target value, and you have verified for all the data. All the data. So this is how a perceptron network will train the network. Similarly, you can go with the R. The same procedure can be given for R operation to design the neural network to find out R gate. And the important thing is here, by using the single layer perceptron model, you cannot design a XOR gate. XOR gate, the reason for difficulty in designing or implementing of XOR gate by using neural network is XOR gate will produce a nonlinear pattern. If you observe the pattern of XOR gate, 0, 0, 0, 0, 1, 0, 1, 1, 0, 1, 1, 1, 0. So 0, 0 is 0, 0, 1 is 1, 1, 0 is 1, 1, 1 is 0. So when you take a decision line, you cannot have single decision lines to separate zeros and ones. This pattern and this pattern. This is a non-linear data. So you cannot be separate by a perceptron rule. But there is a other way. For that, what you have to do is, if you observe the AND XOR gate, this is output of XOR. Now 0, 0, 0, 1, 1, 0, 1, 1. If I use NOR gate output is 1, 0, 0. And if I use AND gate output is 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1. Again, if I use NOR gate, it is 1, 0, output is 1, 0, 0, 0. Again, if I use NOR gate, 1, 0 output is 0, 0, 0, 1, 0, 0, 1, 0, 1, 0. So this is nothing but your XOR output. So you can design a XOR gate even though it is a non-linearly classified by using, see, your X1 and X2 or AB, whatever maybe you take, is given to first NOR gate, and the same thing is given to AND gate. And this output is again given to NOR gate. So this is a multi-layer perceptron. So when you want to classify a non-linear data which cannot be classified, you have to go for deep layers. Nothing but deep learnings. Or you have to go for multi-layer perceptrons. You cannot classify XOR gate by using a single perceptrons. For that, as the perceptron rule or the gradient is only for linearly classification, for that we had a non-linear classifier, that is delta rule or back propagation algorithms. So this completes the perceptron things, and next we will see how a deep learning network exactly will work on the system. See, coming to images input, any deep learning networks, you will have two layers. One is convolution layer and pooling, a combination of convolution layer and pooling layer. Another one is fully connected layer. A combination of convolution layer and fully pooling layer. Suppose if I give the system X, suppose this is a 22 by 22 by 1 matrix. To represent this image, I required the number of input neurons are 22 into 22. That should be the number of input neurons what I required. And these pixel values where it has some content in the image will be marked as 1, and the remaining blocks will be marked as -1. That is what exactly happening in the process. So this is my cross. This cross, I have marked this as 1, 1, 1, 1. And where this is not having any values, I have marked as -1. So this will be a rhombus. I have marked as 0, 1, 1, 1, 1, and remaining parts are -1. And this reflects a diagonal which is having 1, 1, 1, and remaining are -1. So actually, convolution and pooling layer is a layers where you will divide the images into pieces. And a fully connected layer is a layer where by using these information of these pieces, again, you'll reconstruct the image. But what exactly happening, what the algorithms will perform is they convert this one into so if I take a 2 by 2 mask to perform the convolution operations, I will have 2 power 4, that is 16 types of masks. You can take any of these category of masks. But when you are performing the masking operation, you have to select a particular mask such that it should give the maximum output. So consequently, I am considering these two masks. Now, this is my shape X. I'm applying this mask. See, while applying this mask, here 1 plus minus of minus plus 1, 1 plus 1, 2, minus of minus plus 1, 3, plus 1, 4. So this reflection value is 4. Again, just I have shifted the mask here. Now, -1 plus into minus minus -1, minus into 1 -1, minus into 1 -1, minus into plus minus. The total resultant value is 4, -4. It will be reflected here. And in this case, it is minus into minus -1. This mask is shifted now here, and -1, -1, -1, -1. It is posted here. Again, this mask will be shifted here. It is +4 here. Similarly, you perform the convolution operation with another mask. Then you will get this matrix. See, this mask is having a diagonal value +1. So the system will represent this with a diagonal value, this one. and -4 will be a pixel with 0. And -4 will be a pixel with 0, and 4 will be represented with a diagonal. Here also similarly, since this is the 4, you represent with diagonal, and this is the 4, you represent with diagonal. This is what will happen in the convolution layer. Similarly, I have done for 0. 0, you have 1, 1, 1, 1. You apply the mask here, minus, plus, minus, 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 minus. The resultant is -4. For applying 4, 4, -4. If I apply this mask here, this is 4, -4, -4, 4. Since this mask, see the diagonal direction is this side. So for +4, this will be the diagonal, and for +4, this will be diagonal. -4, you are not representing any value. -4, you are not representing any value. Similarly, we will have for this one diagonal. So diagonal, if you apply, so this is the matrix. Since in this matrix all are negative values, so you have this one, and here it is +4 and +4. True thresholds are there, so it will be this one. Now, after this, what the exactly pooling layer will do is it will take this bit of information, and the next is this bit of information. You are converting a 2D into a single dimension. This bit of information and this bit of information. Similarly for this bit, this one, and this one. Similarly for this one, this one, this one, and this one. So this pattern is for X, this pattern is for 0, and this pattern is for diagonal. Okay. Now you have two masks, one is upwards and another one is downwards. So already we have known that this one is this, this one is this, this one is this, this one is this. Now I'm considering this downwards diagonal. Now I compare this downwards diagonal with this. Both are same in pattern, so I will assign 1. Both are opposite in pattern, I will assign -1. Again, if you compare these two, both are opposite in pattern, you assign -1. Both are same in pattern, you assign 1. Come to this one. Both are opposite in pattern, -1. Both are same in pattern, 1. Both are same in pattern, 1. Both are opposite one pattern, -1. Similarly here, opposite, -1. Same, 1. Same, 1. Opposite, -1. Same, 1. Opposite, -1. Opposite. Only you see the direction. This you take this block and you compare with this blocks. You take this block and compare with this block so that you will get these values. You take this block and you compare with these blocks. No, -1. Opposite, -1. Opposite, -1. Opposite, -1. -1. Same, 1. Same, 1. No data, -1. So once this one is there, the filters what we have used previously is these two filters. Now that fully connected layers will use these two filters to reconstruct the structure of the image from this data. See here it is plus, so it is plus 1 minus plus. See this is plus minus 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 plus plus minus minus plus 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 minus. So this is the filter pattern for identifying of X, and this is the filter -1, 1, plus, minus, plus, minus, minus, plus pattern for identifying of 0, and this is the pattern for identifying of diagonal. 4 -1s, so minuses, minus plus plus minus, minus plus plus minus. Now in fully connected layer, these filters, these three filters are applied for the, suppose if I give input as a X for the mission, this full connected layer, for the X, the pattern is this. The cooling, the convolution layer and pooling layer will generate a pattern, this one, for that particular value of X. So this is the pattern generated by the convolution layer and pooling layer. Once this pattern is generated, the function of the fully connected layer is, for this pattern, it has the filter. It compared this pattern with these filters. It is having a predefined filters. So this pattern, if I compare with the filter, plus 1, minus of minus plus 2, minus of minus plus 3, plus 4, minus of minus plus 4, plus 5, plus 6, plus 7, minus of minus plus 8. So for this pattern, this filter has scored, or this neuron, particular neuron has scored a value of 8, and you see the other neurons. Minus 1, plus of minus 1, plus of minus 1, plus of minus 1, plus of minus 1, minus of minus 1, minus of minus 1, plus of minus 1. So if you add all these things, this is nothing but minus 8. Now come to this pattern. Minus 1, plus 1, plus 1, minus 1, minus 1, plus 1, plus 1, plus 1, plus 1. So its value is 4. So among these 3 neurons, the first neuron is having maximum value of 8. That indicates that the input pattern what you have given is related to this X. The input pattern what you have given is related to X. So that since it has scored the highest value, the computer or the machine will recognize that input pattern as X. FDP. The input pattern as X. Next, if you see in a similar fashion, I have given the input pattern as 8, where your convolution layer and pooling layer will generate a matrix. For the 8 is this one. This is how we have generated. We have seen in the previous slides. When this one is generated in the fully connected layer, now these filters will be applied for this pattern and it will find the score. For this first filter, the score for this pattern is minus 1, minus 1, minus 1, minus 1, minus 1, plus into minus 1, minus 1, plus into minus. Total the score is minus 8. For the second filter, minus of minus plus 1, 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 plus. The score is 8. And for third filter, the score is minus of minus plus, minus, minus, plus, minus, plus, plus, plus. The score is minus 4. Since the maximum score is given by the second filter of the second neuron, that means this is a valid score. So the pattern what you have applied is 0. In a similar fashion, it can recognize diagonal. So this completes my lecture on AI and ML. If you had any doubt, you can ask me. Thank you.
Participants, any questions? If you have any questions, you can ask. Sir, Srinu sir, any questions are posted in the chat box?
Sir, if there is no question, we can wind up for this session.
Hello.
Yeah, if there is no question, we can
Hello.
wind up this session, sir, by saying thanks to
Hello.
our expert, Dr. Krishna Kishore. Is it audible, sir?
Hello, sir. Hello.
Yeah,
am I
yeah,
audible?
audible, sir, audible, sir, Kannan, sir.
Yeah. Yes, sir. You thank our expert.
Hello.
Yeah.
Hello,
you
sir.
can
Am I
thank
audible?
our-
Sir,
Yes, sir,
somebody is
yes,
asking,
Hello.
sir.
Yeah, any question is there, sir? You can ask.
Hello, sir. Am I audible?
Yeah,
Yes,
yeah,
sir.
audible, sir, audible.
Okay. Sir, for audio recognition, which technique we use for a classification or a regression technique? Hello.
Sir, audio recognition, you want to identify the audio belongs to which person?
Any data for music? I have a musical data set.
Okay.
So I have to identify the suppose a region wise audio classifications. Suppose
Okay.
in North India there is a new audio something like as a tonality is different from the different region.
Yes.
So how can we identify the different region tonality and how can we classify the differentiate?
Whether it may be image or audio or anything, we have to see, the system will see as a data.
I have a data set as audio data sets.
Yeah, audio data set.
Yes.
Audio data set, finally, after extracting the feature, it should be in the form of a matrix. Values.
Okay, I mean I have to convert in the first in the image data set.
No, data.
Data. Hello.
Means
Yes.
data means the values. Suppose,
Okay.
suppose if I'm talking about a identification of numbers 0 to 9,
Okay.
when I'm writing the number 1, what I will take is what is the pressure I'm keeping and what is the time taken to write the number and what is the position of the number. Those are the features the machine will take from the particular data. Whether you give the image, suppose if you're giving as an audio, that should be converted into the Excel file with some features.
Okay. Means I can convert into the particular time slot duration.
Yeah, time slot duration and the pitch and the vocabulary what they're
Pitch.
using.
Okay.
Yeah, those are the features for your audio file.
Okay.
And depending upon these these features, you have to apply the classification algorithms.
Okay. Okay. Yes. So suggest me the which classification algorithm we can apply for the better solution.
Sir, which classification means you, since when you're talking about this kind of things, whether you have to go with the label data, that means this particular reason people will have these type of audios, then you go with the supervised algorithms, supervised learning.
Supervisor.
No, I don't want to give the labeling. That means actually by depending upon the pitch or depending upon the time duration, depending upon the vocabulary, the machine has to identify the features and it has to tell what particular cluster or particular class it is coming on. Then you go with the unsupervised learnings.
Okay. So after
When I go for supervised learning, I know what is my output and what is my input. Depending upon that, I will train the machine. Like I know I'm catching an apple. I will train my baby that this is apple, this is apple, this is apple. After a certain period, when I'm showing that particular objective, that baby has to detect this is apple. That is supervised.
Okay. Yes, I can understand.
Yeah.
Okay. Thank you, sir.
Okay, sir. Thank you very much.
Sir, thank you, sir, Kishore, sir. Very good, nice presentation. Thanks for your valuable suggestions to our participants. So, any participants from any queries from participants? Okay, sir. Thank you, sir. Thank you, Kishore, sir.
Sure, sir. Thank you very much for
And
your
thank you, sir.
a very nice presentation and also the answers which you have given to our participants. Thank you very much, sir. Thank you. Thanks a lot. Yeah, for the participants, you please join by 6 o'clock for the session 2. Dr. Saravanan sir will be there for the session 2.
you.